Hello everyone, welcome to my channel Mathenthusiasm. This video is day 30 of the 30-day challenge. It is all about integration by parts. Let's check it out. Integrate log x times arc sine x dx. Before we talk about the method of solving, let's start with the range of values of x. For log x to be real, x is larger than 0. While for arc sine x to be well defined, x is more than or equal to 1. We put the two conditions together like this. This is important at the end of the video. Now we have to decide which term should be absorbed into the differential. Because log x is logarithmic function L, while arc sine x is inverse trigonometric function I. By the Layard rule, L is in front of I. So L is U and I is dV. In other words, we have to absorb arc sine x. That is to integrate it. But how to do it? On day 13 of this series, we have dedicated an entire video to integrate arc sine x. You may want to check out the link of the video in the description after watching this one. Here we just make use of the result. Integrate arc sine x dx is equal to x times arc sine x plus the square root of 1 minus x squared plus c. Let's put this into our original integral. Now, the differential is changed. Comparing with the formula of integration by parts, u is equal to log x and v is equal to this bracket term. The first term is a product log x times bracket x times arc sine x plus the square root of 1 minus x squared. The second term is the integral by swapping u and v, which is this one. Now we differentiate log x right here. It is equal to 1 over x dx. We multiply this into the bracket. Then this x term is cancelled out. So the integrand is arc sine x plus the square root of 1 minus x squared over x. Let's separate it into two integrals like this. You see, for the first integral, we make use of the result again. It is equal to this bracket term. At the same time, it is also a common factor. So we can take it out, leaving log x minus 1 at the back. Now we focus on this integral. As we have the term square root of 1 minus x squared, therefore let's use trigonometric substitution. Let x equals to sine theta. So dx is equal to cosine theta d theta. The third square root of 1 minus x squared is equal to the square root of 1 minus sine squared theta, which is equal to cosine theta. Now we put everything into the integral. Therefore, it is equal to integrate cosine theta over sine theta times cosine theta d theta, which is equal to integrate cosine squared theta over sine theta d theta. At this point, how can we move on? For the numerator cosine squared theta, we make use of the square identity, which is equal to 1 minus sine squared theta. Then we can separate the integrand into two parts, which is cosecant theta minus sine theta. This one is not hard to evaluate. Recall the integration formula. It is equal to negative log absolute cosecant theta plus cotangent theta plus cosine theta plus c. Let's simplify it a little bit. We write the terms inside the absolute sign as 1 over sine theta plus cosine theta over sine theta. Then combine the two fractions like this. Now we have to change the variable from theta to x. We have cosine theta is equal to the square root of 1 minus x squared, and sine theta is equal to x from substitutions. Put them into the step like this. Also, we do not have to use absolute sign. Why? Because x is between 0 and 1. So the square root of 1 minus x squared is larger than or equal to 0. That means the numerator 1 plus the square root of 1 minus x squared is larger than 0. We can go back to the original integral. Put the result inside like this. Let's do some simplification. We multiply x times arc sine x with log x minus 1. Then, for the term square root of 1 minus x squared, we expand it like this. Let's move on to the last bracket. The two negative signs here give a positive. Moreover, we separate the log term into log a minus log b. For the remaining term square root of 1 minus x squared, it is negative. Now, it's just one step to the ultimate answer. For the first term in green, we just leave it in the front. Next, we have two terms with log x. Let's take it out as a common factor. We also have this large log term. Then we're left with the two sets. So the final answer is equal to x times bracket log x minus 1 times arc sine x plus log x times bracket the square root of 1 minus x squared minus 1 plus log bracket 1 plus the square root of 1 minus x squared minus 2 times the square root of 1 minus x squared plus c. I would like to express my sincere gratitude to those of you who stay tuned with me about this journey of 30-day challenge. See you in the next video of calculus.